Kia ora, we're pushing on, we're on page 70 now. Okay. Pumpkins from a large crop are found to have a mean weight of 4.1 kg and a standard deviation of 0.45 kg. I should have done my own example for this, but maybe having a walkthrough is helpful for you guys. Okay, so mean equals, oh shucks, what was it? 4.1, standard deviation 0.45. Calculate the probability, so that means I've done this, I've done that. Calculate the probability that a pumpkin weighs between 3 kg and 4.1 kg. 3 kg, that's going to be to the left of 4.1. And it's actually going to be over 2 standard deviations to the left. It's going to be really deep, like way down there. So it's going to be between 3 kg and 4.1 kg. Let's write it out as a probability statement. P3 is less than the pumpkins. So the pumpkins are greater than 3, but also the pumpkins are less than 4.1. Right? Pumpkins are between 3 and 4.1 kg. Perfect. Okay, let's shade in what we want here. It's this. We are looking for this shaded area. Oh, it's pretty ugly shading. But better. Okay, now we want that probability. Okay, so this is our x, and let's draw our proportional z, and we'll see what we can do with z to deal with it. Oh yeah, we're getting better. We're getting a bit better. I don't like this little thing here, but we'll work on it. This is a really fun thing to do in your spare time at home. It's just practice drawing your normal distributions perfectly. Maybe not in your spare time, just like work on your bookwork and really cherish the moments where you get to draw the normal distribution. Yeah, it's great fun. It's like drawing a perfect circle. Okay, we'll draw this on here. This is Z. Now, what is the problem here? The problem here is that our Z tables, they do to the right. They only go to the right of the flippin' of 0. So is this useless to us? No. Remember, the big thing about the normal distribution is that it is symmetrical. Symmetrical. I don't know how to spell that, but that'll do. It's symmetrical. That means whatever happens to the right, is gonna be the same as what happens on the left. So we could actually, the way I like to think of it, and it may be a little bit wacky. That is wacky, right? We're looking here, but when I'm going left of 0, I'm actually looking at this value here, which I'm going to label, or should I label it? No, let's transform Z first. Let's transform it, and then we'll explain it from there. It will make more sense. So let's do our transformation first. We're going to find out what our Z value is. So what are we doing here? We're doing Z equals x minus mu over the standard deviation. Okay, so our little z is going to be x, which is 3, minus our mean, which is 4.1, over 0.45, which is our standard deviation. Let's get our calculator up. I was explaining last lesson that we need to use our calculators as often as possible so we make less mistakes. 3 minus 4.1. Of course, that's 1.1. It's so obvious. Why would we use a calculator? Because sometimes the calculator is smarter than humans. Because the calculator doesn't make little brain errors, right? It's actually a negative number. So we're getting negative 1.1 and then dividing it by standard deviation. So divided by 0.45. Ooh, we've got a negative number. Damn. So Z is actually negative 2.444. Why is it negative? It's negative because it's left of 0. So what we're getting here is that Z equals negative 2.444. Now, our table doesn't do that. Our table doesn't have negative z values in it. So we're going to have to use the fact that it's symmetrical. So we're going to do some mirror imaging. Look at this. So we've got z here. What we're going to do is we're going to pretend that we have... I'm stalling because I'm trying to find my cell phone. Cell phone shows this nicely. Usually. I wonder if it'll work on this. Right. A girl in my one of my low band maths classes showed me this. Is pretty cool. We were doing reflection tasks and she showed me to use her phone. So pretty much we're going to use the fact that it's symmetrical, and if we chucked a mirror, notice that this shading here is exactly the same as the shading on the right, right? And over here, our z value, we can mirror our z value over here. And so what I'm going to do is I'm going to write negative z equals, and I think this is sort of a notation thing, so maybe you should be very careful with how you use this. I may correct myself in the future. 2.444, right? Because it's symmetrical, we can mirror it. So this one here, we can shade it in that whatever is happening on the left, we can mirror it over, and we know that whatever would have been here in pencil is exactly the same probability that's showing up on the right. So now we can just look from 0 to 2.444, and that probability is going to be exactly the same as the probability on the left. So let's do that. 2.44444 is down here. So we highlight that. So this probability here, the probability that it's between 0 and 2.444, right, is going to be, so we go to 2.44, so it's 0.4925. Oh no, it's not. Oopsies. 0.4927. 0.4927. And then we're going to add on a difference of 4. And a difference of 4 means we just add on a 1 to the last digit. So it's 0.4928. Whoopsies, did it in my head. My bad, guys. Now, let's go back and use some logic. So we found this one, 0.4928. And we know that that's a mirror image of what happens over here. So we can then go over here and go 0.4928. That means we now know this probability here is 0.4928. Nice? Nice. Fantastic. So the probability that a pumpkin weighs between 3 and 4.1 is 0.4928. Fantastic. Okay, let's move on. We'll try and get page 71 done, and then... well, I guess we'll do another video after that again. Okay. Blah, 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 blah. Similar story here, but we're just going to go to the other side of it. Cool. Let's do it as quickly as possible. In fact, I'm just going to do I'm going to show you without heaps of working. So if I was being super lazy, this is how I would do it. I'd write 4.1, 0.45, calculated probability less than 3. I'd just draw a line anywhere here. 3 and less than, I would color that in. I'd do my final statement straight away. P, that pumpkins are less than 3. That's the statement I'm going for. I'd label that X, quickly draw a distribution here, label that Z, do this, highlight there. I know that it's mirrored, it would be over here. So this is what I can find. This is what I'm looking for. So then Z equals 4.1. No. Yes. No. Z equals X, 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 X. 3 minus the mean is 4.1 over the standard deviation is 0.45. 3 minus 4.1, negative 1.1. No, it's not a nice number. Calculator. 3 minus 4.1 divided by 0.45. negative 2.444. So that means this is 2.444. Then let's find this probability. Oh, we found it from before. It was 0.4928. If that is 0.4928, we then know that that is the same as this using a mirror. And then to get to this chunk here, which is the one that's important to us, we're going to need to do 0.5 minus this chunk here. And we know that this chunk is equal to the same as this chunk. So it's just going to be 0.5 minus 0.4928. I'm going to just make it a little bit clear. That there is also 0.4928. So 0.5 minus 0.4928 is going to get us 0.0072. Let's just say I had a calculator here. Okay, that means that this probability here is proportional because it's the one above, 0.0072, and then that's the answer. Cool.